Today's video starts on page 3, or 3A, because there's 2 pages 3. But the problem of the day, page 3, video 8, David says that he bought 9 apples and 6 apricots for $8.50 yesterday, and bought 3 apples and 2 apricots for $7.40 today. Letter A, write a system of equations to find the cost of an apple and an apricot. Letter B, state with reasons, plural, whether the system of equations has a unique solution, one answer, is inconsistent, no answer, or is dependent. They're the same line, they're multiples of each other. We've already seen this. So answer letter B, and then C, what does this tell you about the cost of apples and apricots on these 2 days? So answer all 3 parts of that, work out the equations, the system of equations. Let x equal apples and y equal apricots, since A and A won't work. That would be a great idea to use x and y. Number 2, graph 3x minus 5y equals 4 and x plus 2y equals 5 on the same coordinate plane. I did this one, and what happens is if you put your coordinate axis exactly, your x and your y axis exactly in the middle, and you guys can see this, that I know that my slope is going to be 3/5. Up 3 and over 5, well, I can't do that because I can only go over 4 to the left or 4 to the right. So, don't like this. I do not like this, but for this time only, I'm going to allow you to add on another, just a line here to show that that's like x equals 5, and this is x equals -5. So you can do that slope of 3/5 for the first graph. The other graph works out just fine. Find the point of intersection of these graphs. So I'm allowing you to add on to the graph paper only this time. Should have put a bigger piece of graph paper on this, but it's not there, so never add on to graph paper in other times. Inconsistent and dependent systems of linear equations. We've already seen this where they have no solution or infinitely many. So I'm going to go through these pages fairly quickly. Consider this system of linear equations, 2x plus y equals 1 and 4x plus 2y equals 4. Look what happens when you try to solve the system of equations. So you try to eliminate it or substitute it, and they tried to eliminate it, and you get 0 does not equal 2. Because 0 does not equal 2, this has no solution. You get a false statement. Sometimes when you try to eliminate a variable, you end up eliminating both of them, and then you cannot have a unique solution. You get 2 constants that either equal each other or 2 constants that don't equal each other. 0 does not equal 2. A system of equations with no solution is considered inconsistent. No solution, inconsistent. Looking at the tables, you can see that the table of values, when I go to graph those points here, these linear graphs have the same slope, right? They both have the slope being -2, but their y-intercepts are different, which means if their slope is the same, they're going to be parallel if they have different y-intercepts. The graphs of these equations are parallel lines, so there is no point that they're going to intersect. Since there are no points that lie on both graphs at the same time, the system of equations has no solution. Here's another unique way of looking at this exact same system. 2x plus y equals 1 and 4x plus 2y equals 4. Compare the coefficients of the x and the y. So 2 to 1. To 1 is the constant. That's the first. And then 4 to 2 to 4. That's the second equation. 2 times 2 equals 4. 1 times 2 equals 2. But they're not in the same multiples. This is 1 times 4. Because they're not multiples of each other, it will give you an inconsistent system of equations. So there's not going to be, they're not multiples of each other. There's going to be no solution. So let's see if we can look at the coefficients and try to make the equations look the same. State whether each system of linear equations is inconsistent. Justify your reasoning. Okay, I'm going to multiply the first equation by 2. So I would get 22x plus 2y equals 4. And then the second equation is, 22x plus 2y, looking good so far. Oh, it's 3. Since these are not multiples of each other, 4, when we go to subtract these two equations from each other, 4 will not equal 3, so it's inconsistent. They are not multiples of each other. 1/3 x plus y equals 7, and x plus 3y equals 6. Well, if I clear that ratio there in first equation, 1/3 times 3, that will give me x plus 3y equals 21. Oh, and the second equation was x plus 3y only equals 6. Not multiples of each other. 21 would not equal 6 if I subtracted these equations from each other, right? I would get these, everything would cancel, right? And I would get 21 doesn't equal 6, doesn't equal -6 if I'm subtracting them. So 21 isn't the same as 6, so again, it's inconsistent. I don't even have to finish solving it because I know I'm not going to get a solution. Next page. Consider the system of linear equations x plus 2y equals 2 and 2x plus 4y equals 4. And when you solve it, you get, when you substitute and do everything, you get, look at that, we get 4 equals 4. And I can see that the top equation times 2 is going to give me the bottom equation. They are multiples of each other. So they are going to have an infinite number of solutions. They are a dependent system of equations. So when you go to graph them and they show you all, solving it for y equals, my slope is exactly the same, -1/2, and my b equals 1 in both of these, -1/2 and b equals 1. Oh my goodness, they're the exact same graph. When two linear graphs have the same slopes and y-intercepts, the graphs are the same. This system of linear equations has an infinite number of solutions. It's called dependent. Identify whether the following systems of linear equations are dependent. Justify your reasoning. If I can get them to be the same, let's see. 4 times 5x would give me 20x plus 8y equals 16. And 20x plus 8y equals 30. From the last thing. Those aren't the same, so this is going to be not dependent. Say whether they're dependent. They are not dependent. They are actually inconsistent. They will not have a solution. They are inconsistent. The second set, let's see, if I multiply the top equation by 4, I get 28x. Let's multiply it by -4. -28x minus 4y equals -56, and 10x plus 4y's equals 32. I'm going to get my y's to cancel. I'm going to get to solve for my x, and this is going to have a unique solution. So they are not multiples of each other, not dependent. It actually has a unique. They are consistent. They have a unique solution, or what is called consistent equations. One answer. Those lines are going to cross. Number 7. Can I get these to be multiples of each other? Well, I can make 36's out of those x by multiplying by 3. So I get 36x plus 12y equals 48. If I multiply this equation by 4, I'm going to get 36x plus 12y. Oh, equals 48. They're exactly the same. 48 does equal 48. They're multiples of each other, so it is dependent. They're going to end up being the same linear equation when you go to graph them on the line because they are multiples of each other. And that's it for today's video.